Hi and welcome to the fourth tutorial of Houdini FX. In this tutorial we will be learning how to make a scene with clouds in it from our basic geometry setups as well as using some metabol nodes. So to start this tutorial we will first take up any geometry node onto the scene. I'll take a box here. With this box onto the scene I am going to open my panel where I've got this new network view, and here we'll just go into the geometry level, and I don't need a box here. Actually I needed a node onto the scene, so I'm going to get rid of my box node here and I'll quickly add a sphere node because we'll add a sphere node to the scene. Now along with this sphere node I am going to add a grid. This grid is going to be basically what we call as a plane, and we've got a grid here and we've got a sphere here, as you can see. Now with this two objects on the scene, the idea right now is to populate this entire plane with my sphere. So to populate this entire plane, what we need to do is we need to add a node called copy. So I add a copy node here, and into the copy node goes my sphere, and into the copy node second option or second input goes my grid. If I bring the focus to copy, you can see that all those points or all those vertices inside the plane have been converted, or rather have taken a sphere at their center points. So this looks a bit congested here. So what I'm going to do is I'm going to come to my grid and I'm going to shoot up my size to somewhere around 20 by 20. So this loosens up the arrangement somewhat, but still if we take a look here, what is happening is all these spheres are looking very ordered. Now if I am talking about a cloud is not something which is going to be very ordered. There is going to be a lot of randomness into it. So first and foremost, our target right now is to add a randomness to these spheres which we have in this plane. To do that, I am going to add a node called scatter. We have used the scatter node earlier in our Voronoi fracture tutorials also. Click on the scatter node, you can see that the number of points is set to 5000. Now we don't need that many points. I am going to bring this down to somewhere around 80 points. Alright, and I am going to connect this grid to my scatter, and in turn my scatter is going to go inside the copy. So what happens here, you can see that these sphere, they have got kind of disturbed, that entire regularity, the entire the pattern, the arrangement that was there, that has got disturbed now. So if you see this disturbance is there only on the x and the z plane, the x and z plane. This disturbance is not there on the y. So now we need to spread, or we need to rather translate this same disturbance onto the y axis also. So to do that, what I am going to do is I am going to add a mountain node. This is my mountain node here, and I am going to connect my grid to my mountain, and I am going to take my mountain to my scatter. Now why are we doing this? I just press L to arrange my network. Let me just come back to my grid. This is I have shifted the focus to my grid here. Okay, let me shift my focus to the mountain. What this mountain basically does is it is going to add a certain noise to the way my entire structure is visible. Now my height is set to 1. I could shoot this height to somewhere around 4 to get a different displacement onto the points. Now as you already know, because of the copy node, each of these points are going to take the sphere. So I have done this. Now all I need to do is I am going to shift my focus to copy, and here you can see that the spheres are now disposed onto the y axis also. Alright, that being done, now we need to change the radius, or need to give random radii to each of these spheres. Now to do that, this is where our copy node is going to come into play. I'm going to take my copy node here and I'll just pull this down. Copy node has something called as a stamp inputs. Via stamp inputs, I can create a variable. Now I am going to create a variable called random x, and for this I am going to set an expression which says to take random of $pt. pt is basically, see, this random function needs a seed to work with. So this entire seed, this seed is going to come from the point data of my sphere. So I have given random $pt, and I am going to simply offset it, or rather increase its value by 0.5. Random is going to take values between 0 and the pt point which we have given. But the problem is, if it takes too low a value, then the displacement might not be very clear. So I am going to add 0.5 to this, hit an enter. Next I am going to add random. I have done it on the x, I am going to do it next on the z, random z, and I am going to give it random of $pt. I can give it a different value. See, this is basically a seed value which I have given pt there. I don't want to give the same pt here, so I am going to give a different random value of random $pt into what, maybe 6, right, plus 0.5. So I have got two variables, random x and random z. I am going to switch on stamp, which is going to tell Houdini's engine that random x and random z are two variables which are going to give these input values onto different attributes. So let me come back to my sphere here. Inside sphere I have got radius set to 1, 1, 1. I am going to go into my x radius and I am going to give this as stamp. To open my quotes, double dot, slash. It brings in all the nodes which are there present into my network view. I am going to take copy 1, close the quotes, comma. I need to mention which stamp token of copy 1 is going to influence the radius x. So it is going to be random x. So I am going to take random x, comma. In case random x generates a value which cannot be put into my sphere, let's say it's something which is too low or which is not making sense, in that case I am going to add 1, which is going to be my default radii. So I hit enter here. Now automatically you can see that all these spheres have gone random changes on the x. Now we are going to repeat the same process for the z also. So let me click here and open stamp, same process, quotes, double dot, slash. I am going to take copy 1, close the quotes, give the variable which is going to take the value random z, again set the default value and hit enter. So now you can see I've got a variation on the x and on the z, right. Now I need to give the same thing for my y also. For my y, what I will do is, instead of making a different altogether random y, which we can as well do, we can always pick up this random x or this random z value. So what I'll do is I'll pick up the random z value here. So I'm going to write here, and I'm going to pass it through a sine function. I'm going to write a sine channel, because I need to pick up that channel, colon dot slash, and it is going to be radius z, right, and colon bracket. Now what has happened is, we all know that why we took this. See, this sine basically generates a wave. Okay, we all know that if I'm going to enter any value between minus infinity to plus infinity into my sine function, my result is always going to stay between minus 1 and plus 1. That we have all learned that in our high school physics. So what we need to do is, we need to actually augment this sine function here with a multiplier which is going to shoot up this value. So right now my sine value is this. Let me just multiply this by something around 30. So again you can see I've got this randomness in y, which is more or less somewhere connected with my random z. So I have kind of made this where I have got these spheres and everything set up randomly. Let me just come back to my network here now. Okay, after I have come back to my network, I'm going to connect this copy here to one more mountain node. So let's connect it to a mountain node and bring it here, and I'm going to increase the height to somewhere around 4. Okay, let's focus onto the mountain. What's gone wrong? Okay, right. Come to sphere. See, basically mountain is something which is going to work on polymeshes. So come to sphere. You can see here my primitive type is set to primitive. I'm going to change this to polygon mesh. Okay, yeah, it's worked. Let's come back to mountain and let's just tone this down. I would like this down to somewhere around 0.5 or something, which is going to add a certain amount of I don't need this wireframe shaded. Let's keep it at smooth. Yeah, so this is what we are generating, and I'll just tweak onto this height slightly to see whether we get a proper output here. Yeah, so I've set my height to somewhere around 0.8. Now what I need to do is I need to populate this. I need to generate points here first and foremost. So because I need to work with metaballs, so what I'm going to do is I'm going to add here points from volume, and inside my points from volume, point separation is set to 0.1. I'm going to change this value in the beginning itself, because if it's at 0.1, it's going to calculate a lot of points, and it's going to take my system resources. So I'm going to shoot this up to somewhere around 0.5, and I'm going to connect this to points from volume. Let's switch this on and we can visualize the points here. Yeah, these have been converted into points now. All right, now what we can do is we can take these points and convert them into metaballs. Rather than saying convert them into metaballs, these points data can be sent into a metaball node, so that each of these points will be represented via metaballs. So how do we do that? We are simply going to add a metaball node here, and I'm going to add a copy node once again. Add a new copy node. My metaball goes into input 1. Sorry. Yeah, metaball goes into input 1. My points from volume goes into input 2. Right, and let's just visualize this. Yes, we've got our metaball here. I'm going to reduce onto the radius of my metaball so that I can catch on to more details here. So this radius is set to 111. I'm going to bring this down to somewhere around 0.4, 0.4 and 0.4, so that the details are there. I think it's come a bit too down. Let's take it to 0.6, 0.6 and 0.6. Yeah, that's much better. If required, I can always crank up the points distance here. It's at 0.5. Let's take this to 0.3 if possible. Obviously it's going to take some time. Yeah, that got cranked, and let's just shoot up my mountain height slightly. I would like to take this to somewhere around 2. Yeah, so you can see that increases the randomness of this entire setup. All right, so we've done that. We've generated a mesh from spheres, which from a regular arrangement of spheres into something which is looking a bit more distorted, something which is looking a much more random. Now to this I am going to add a new node. I am going to add a mountain node. Connect my copy to my mountain and switch the focus to mountain here. Right, let's increase the height now. Let's increase the height to 3. What happened? Is the focus here? Yeah, the focus is here. Something seems to have gone wrong. Let me just check what happened here. Okay, let's bring this height to 1 here, and let's check this where we have. Okay, that seems to something has gone wrong with the network. I'm just going to cut out of this and come back. Okay, we need not take that mountain node, that was not required. So we'll continue with the copy node here. We've got these points visualized here, and we've got this mesh here. So coming back, I'm going to shoot up my mountain height here to somewhere around 5. I'll come back to my copy node, and let's see how this has come up. Yeah, so we've got a lot of randomness here. Maybe not up to 5, maybe 5 is a bit too high here. Let's bring this down to 3 so that it calms down things a bit. Right, so we've got this structure here, which is more or less going to resemble the entire topographic nature of a cloud. Now once we've done that, we need to start with our volume rendering. So I'm going to add a node called ISO offset. So I've added an ISO offset here, and I'm going to connect my copy into my ISO offset and bring the focus to my offset here. Now let's see what we have here. You can immediately see, since it's going to go into volume rendering, there's immediately it has taken up this cloudy, foggy shape. The mode is right now set to the mode is right now set to ray intersect. Okay, I'm going to change this to metaball, since we are working with metaballs. And the sampling, this entire blob, this level of this blob which is looking, the entire quality of this is going to depend on the sampling. My sampling is right now set to 10. I'm going to shoot this up to somewhere around 200. Obviously it is going to take some time. I'm going to pause here and just shoot back once this cooking has been done. Alright, now the cooking has been done. You can see that I've got this fairly easy setup which looks like a cloud. Now we need to add a certain shader to it so that the rendering becomes smoother. Now I'm going to just save my file quickly here as cloud, and open my view here. It's very easy to add a shader. We'll go to a new pane type and pick up a material palette. Here if you scroll down, you've got something called a billowy smoke. Basically that's how your cloud actually looks like. I'm going to come back to my object level here, zoom out, come to my material palette. I'm going to drag my billowy smoke and leave it onto my object. Now here my billowy smoke shader is here. I'm going to add a new mantra node and get this done. Now this mantra node will actually help you in rendering. I'm going to stop my lesson here. You can see this outlines which shows how the cloud has set up. In the next lesson we will be going into the shading and lighting aspect of this cloud. Would appreciate a feedback sent from you. Thank you very much.